Welcome to Sundar's lecture. This is lecture number 73, and in this lecture we are going to see transient responses of RC circuit for AC input, right? See, we have connected R and C circuit in series. We are connected R and C in series, and we are exciting the circuit with the sinusoidal input. AC, in sense, we are going to give the sinusoidal input. That is nothing but it is V is equal to Vm sin omega t, right? So the current through this one, maybe I have written it as I into R, anyhow this is wrong. So this value, it is actually I, or you maybe write it as I of R, I of t. So now the voltage across the capacitor, I am just taking it to be V into V of t, right? This is the expression. And now we are going to write the KVL expression for this circuit. So if you are writing the KVL expression, what you will get? So KVL. So start from this point. So this will be plus minus. We know this one. This is plus. This is minus. And the current is flowing in this direction. So it will be V and then minus I into R. Maybe I of t or I into R. You just try to understand me. And then minus. Oh, okay. This is actually V of t. Maybe this is small v. This is capital letter V. You try to understand. Maybe I will write this one. That should be is equal to 0. Anyhow, if you are writing the expression, what you will get? You will get I of R minus V of t. Sorry, plus V of t. You bring both term to the other side. And what is the value of V? V will be is equal to Vm sin of omega t. And what is the voltage in the capacitor? If the current is flowing from plus to minus, then obviously the circuit current will be C into dV by dt. We know this one, right? So you just substitute, instead of I of t, you just substitute in this expression. What you will get? It will be RC dV by dt, and then plus it is V of t, and that should be is equal to Vm sin omega t, right? Sin omega t. You will get like this. Now this is first order differential equation with some coefficient before the derivative. So what you do, you just divide this expression by RC, divide by RC. So what you will get, if you divide it by RC, you will get dV by dt plus V of t divided by RC, and then this should be is equal to Vm sin omega t divided by RC, right? This is the expression. And you see this expression. Now if you want to find what is the characteristics equation, so what is the characteristic equation? You have to take the differential equation, and you have to equate it to 0, right? So this derivative, you just try to write it as d, and then plus, this is constant, no derivatives are there, so it will be 1 by RC, and that should be is equal to 0. You need to find the characteristic equation by using this expression, and what you will get, it will be d, which is equal to minus 1 divided by RC, and we have found this one. This is actually first order differential equation. If you are solving the first order differential equation, what will be the expression? It will be V of t, it should be is equal to a e power dt, there is only you have only the first order differential equation, then it should be k1 x plus k2 x dot, and then plus k3 x double dot. It will be going to infinity, right? This is the expression, and we know that this value, this V of t will be is equal to a e power minus 1 divided by RC into t, that we know. Then plus k1, what is x here? This is the value of x, so it will be Vm by RC into sin omega t. You will get like this. So if it is x dot, what you need to do, you have to differentiate this equation. What you will get? So if you differentiate sin omega t, you will get cos omega t into omega, right? So this will be plus k2, there is Vm divided by RC is already there, it will be omega cos omega t. That's all, right? So next thing, you need to differentiate this whole term, and maybe this whole thing, everything is constant, right? So what you can do, you just write it as K3, this constant as K3, and then if you are going to differentiate cos omega t, it will be minus sin omega t into omega, and into omega also I am taking it to be the constant. So this will be now, this will be minus, this will be minus, right? So minus sin omega t. And if you again differentiate this one, you will get K4 cos omega t. See what you are getting here, it is very easy to understand. So this value is K1, maybe you take everything as constant, maybe I will write it down for your understanding. See, this is a e power minus t by rc, I can write like this. So this one I am just writing it to be K1 sin omega t, K1 sin omega t. Maybe you write with a different constant, you can use A or B or C, anything it may be, and then this will be now plus K2 cos omega t, and then this value I am just putting plus, what it be, minus 1 or plus 1, it will be a constant, right? So K3 sin omega t, and then plus K4 cos omega t. See, everywhere you go, you can see the constant. This constant, if you take commonly sin omega t and cos omega t, you will have a two different constants. So obviously, what you can write it down here, if I've just taken it to the next page. So this value will be now v of t can be written as a e power minus t by rc. That is one term. Plus commonly I will write k1 sin omega t plus K2 cos omega t. That's all. You just try to understand. You take every cos sin omega t into a single term. If you take sin omega t commonly outside, you will get K1 plus K3. If you take cos omega t commonly outside, you will get K2 plus K4. What is K2 plus K4? Again, it is a constant. And what is K1 and K3? Again, it is a constant. So what you can write this? You see the beauty of getting the solution for differential equation in the classical way. It will be very easy. It will be very, because this is constant, right? Okay, anyway, so now what you need to do, what is this one now? This is solution due to natural function, and this is solution due to forcing function, right? So forcing function alone should satisfy what? Differential equation. Now what is the differential equation here? This is the differential equation, right? So you just substitute different, maybe I will take the differential equation. Now you see this is the differential equation, right? So you substitute this forcing function in this differential equation, you will get d by dt of this v, which is nothing but it is k1 sin omega t plus k2 cos omega t, right? It will be the dv by dt, plus you have to substitute v of t, right? So it will be 1 by rc you will have here, and multiplication of k1 sin omega t plus k2 cos omega t. You will get an expression like this, and that should be is equal to what? It is Vm by Rc sin omega t. Right? You will get an expression like this. And if you differentiate this one, what you will get? So you will get the maybe this expression. This is k1 into omega sin omega t, right? You will get an expression like this. And then see, if you differentiate cos omega t, it will be minus sin omega t. So it will be k2 omega cos omega t. You will get an expression like this. And then plus, see, if you bring this rc to inside, this will be k1 by rc. Here you will get sin omega t, and then plus k2 by rc, and it will be cos omega t, and that should be is equal to Vm divided by Rc, and it is sin of omega t. Try to understand one thing here. This is identity. This is identity. So what you can do? You can just correlate the coefficient with the left hand side and right hand side. So this one, this coefficient of sin omega t, it is Vm by Rc. Vm by Rc. Maybe I will put a different Vm by Rc, and here it is k1 omega, and what you are getting here, this cos, this sine value, this is k1 by Rc. So what you can write here, it is k1 omega plus k1, is this is k1, yes it is k1, so it will be k1 by Rc sine omega t, so not sine omega t, so coefficient of sine omega t, and that should be is equal to Vm divided by Rc. You will get like this. Anyhow, maybe any mistakes? Oh, okay, okay. 1 minute, 1 minute. You see, differentiating this sine omega t, you will get cos omega t, right? So this value, I'm sorry, I have made a mistake. So this value will be cos omega t, right? So here differentiating cos omega t, I am getting sine omega t. I have to get sine omega t, right? So this value will be sine omega t, right? So that is why I'm just seeing out why this is coming. Now you try to understand. So now you see, now this is this value, you should not get this one, right? K1, this is k1 omega cos omega t, and this is sin omega t, this is sin omega t, and you see this value, this is this value, this is a coefficient. So what you can write now, so this is k1 by Rc minus k2 omega, and that should be is equal to what? It will be Vm by Rc. Coefficient can be correlated. And now in the right hand side there is no cos omega t. So if there is no cos omega t, then what you can do? You can just put 0. That's all. What is the cos omega t coefficient? This value, and then this value, right? So what you can do now? You can just write k1 omega plus k2 by Rc. That should be is equal to 0, since there is no any cos omega t values in the right hand side, because this is identity. You can do this one. So what you will get now? So if I want to write down the value of k2, if I want to write k2, what I will get? K2 will be is equal to, if I bring this to the other side, it will be minus k1 omega, and this Rc will be there. That's all. Now this is the value of k2. This is the value of k2. And if I want to substitute this k2 here, what I will get? K1 divided by Rc will be there, minus, and then this minus will be now k1 omega square Rc. I'm just substituting this one. That should be is equal to Vm by Rc. And if I take the LCM, maybe if I take LCM, what I will get? This value will be 1, and it is Rc. It will be k1 plus k1 omega square R square C square will be is equal to Vm by Rc, and this value can be cancelled out. And if I take k1 commonly outside, what I will get? I will get 1 plus omega square R square C square, that should be is equal to Vm, and finally I can write k1 will be is equal to Vm divided by 1 plus omega square R square C square, right? So this is the value of k1. This is the value of k1, and if I substitute this k1 here, I will get the value of k2, right? So I will directly substitute this value now, because I don't need to go further. So k2 will be now, which is equal to minus k1 into omega Rc, right? So it will be minus k1 will be this value, so it will be Vm omega Rc, omega Rc is already there, divided by, this will be 1 plus omega square into R square into C square. That's all. This is the value of K2. Now we know what is K1 and K2. Substitute in this expression. In this expression, you will get the value of V of t, right? So I will just take it to the next page. See, I have just taken it to the next page, and what we can do now, it is very simple, right? So you just substitute the values. So V of t can be written as a e power minus t by rc, then this is k1, so it will be now vm divided by 1 plus omega square r square c square sine of omega t will be there, and then this value is minus this k2 whole k2 will come vm omega rc divided by 1 plus omega square r square c square into cos omega t, right? This value will be into cos omega t, right? This is the value now, right? So what I am going to do now, see what I am going to do now, I am going to take a common term. See, this v of t will be is equal to a e power minus t by rc will be there already. So what I will do, I am just taking vm divided by square root of 1 plus omega square r square c square. I will take this one commonly outside. So what I will get here, I will get this value will be 1 divided by square root of 1 plus omega square r square c square will be there, and this will be sine of omega t, and minus here if I take vm outside, it will be omega rc whole divided by square root of 1 plus omega square 1 plus omega square r square c square, and here I have cos of omega t, right? This is the expression, and now we have came to the point. What is this one? What is the value of this one? This one will be cos theta, and what is this one? This one will be sin theta. This is cos theta and this is sin theta. Please refer my previous lectures. The normal AC signal through RC circuit, you can get these two, sin theta and cos theta. And now maybe I can directly write now V of t can be written as a e power minus t by RC will be there, and then plus it will be Vm divided by square root of 1 plus omega square r square c square will be there, and C cos theta sin omega t, maybe sin omega t cos theta minus cos omega t sin theta, and what is this one? Sin a cos b minus cos a sin b, right? So what we will get here, this is nothing but sin of omega t minus theta, that's all. So this is the final expression. Now this is the final expression for v of t, for v of t. So we have found what is the value of v of t without substituting the initial conditions. So maybe you try to understand this capacitor, before closing this switch, this capacitor doesn't store any energy. So what we can write? So v of 0 will be 0 in this condition. So you need to substitute that value here. If you substitute v is equal to 0, sorry, t is equal to 0 in this expression, and we will get a value, and that a we have to substitute here to get the full expression of v of t. That we will do now. See, we have to substitute v of 0, that intimates it to be 0, that should be is equal to, see, if we put 0 here, it will be e power 0, that value is 1, so it will be a plus vm divided by square root of 1 plus omega square r square c square into sine of, if you put 0, this whole term becomes 0, it will be minus theta. So this value will be now a minus this value, right? Maybe sine theta can be written as what? Minus sine theta, right? Sine of minus theta can be written as what? What? Minus sine theta. So it will be a minus vm divided by square root of 1 plus omega square r square c square, right, into sine theta, that should be is equal to 0. And finally what I can write, a will be is equal to vm divided by square root of 1 plus omega square r square c square into sine theta, right? This is the final expression for a. And now you have to substitute this a to this expression. Maybe I will write it down here. So if I substitute the value, so v of t can be written as what? So V of t can be written as, what is this A? This is the value of A. So it will be Vm sin theta. I can write directly sin theta divided by square root of 1 plus omega square r square c square, and then it will be plus Vm divided by square root of 1 plus omega square r square c square. This value will be sin of omega, sorry, this value, it is omega t plus theta, right? I may get minus. Why should I am getting minus here? Huh? Anyhow, this value will be omega t minus theta, right? So you will get an expression like this, and we can write the V of t expression. What is this value? This is nothing but Ez, right? So this is nothing but the value will be Ez here. So we can also substitute the values of Ez also. It is not necessary anyhow. So this is the value of V of t for the RC circuit. Try to understand one thing. You have to get a good point in this particular place, where, see here, so many students will do a mistake by not taking this as a constant. See, constant, while you are just differentiating the expression, always you take any constant, it may be anything, you have to take it as a constant. Without t, if you get any values while differentiating this expression, it has to be taken constant. Try to understand that one very clearly, and we will take up to the RLC circuit in the next class, and that is very important, very basics for the control systems. You please be with me in next few lectures. We are going to teach, or we are going to learn a very good knowledge through basics of RLC circuits, and that will be very pretty much implemented or pretty much used in the future classes, maybe in control system or in damping systems, and also you can see any tank circuits, you have to go for LC. If it is RLC circuits, then it has to be damped, critically damped to over damped, under damped. So many concepts will come under RLC circuit. We are going to start that in the next class. We will take some extra classes for those topics, because we are going to solve 3 different problems for the 3 different cases, and that will help you to get the very good knowledge about RLC circuit, which will also be going to which is also going to be very helpful in studying control system subject, right? Thank you. We will see in the next class. See, one thing I have missed it out here. Here you will get e power minus t by RC, right? Sorry for missing out this. So what you can write this, maybe I will write it down again. So V of t can be written as Vm sin theta divided by square root of 1 plus omega square r square c square, and here you will get e power minus t by RC, and then it will be plus Vm divided by square root of 1 plus omega square r square c square, and this value will be sin of omega t minus theta. Try to understand this one, and you know that this part it is transient part, this part is a transient part, and this part it is a steady state part, right? After some stipulated time, this transient part will be vanished, and only this steady state part will exist in the circuit. That is the very basics about RC circuits, right? Thank you. We will see in the next class.